friends, I welcome you all in this session. As you are aware, in previous session we were discussing about hypothesis testing of two samples, and we have worked out couple of questions on two independent samples, and we have worked out a question on dependent sample as well. So, you should know what is the meaning of dependent samples. A dependent sample is a sample wherein you collect data from same sample two times. In fact, in previous class, the example which we took, we have seen there that we collected the number of complaints data from salesperson before they went for training and after they attended training program, isn't it? And we found that there was no significant difference before and after. So, the training program was not an effective training program for those group of sales persons, right. Let us look at this question, which is again an example of paired sample or dependent sample, or you may call it related samples. So, at a fitness training center, the manager of the fitness training center, he claims that if you join his fitness center, then weight loss would be more than 17 kg or 17 pounds or whatever is the unit. So, you have to test this hypothesis at 0.05 significance level. Now, he is saying that if you join our training center, then weight loss would be more than 17 kg. So, since you are a student of statistics, you have got this data with you, and the trainer has given you this set of data, and he is saying that the weight loss is more than 17 kg, right. So, these are the weights in terms of pounds of different people. Let us say there is one fellow whose weight was 189 pounds, and then his after attending fitness training center few classes over there, the weight loss is there, right, or the weight is 170 pounds and so on, right. So, 233 to 204. Now, we have to check, is weight loss more than 17 pounds. So, how would you frame null hypothesis? So, there are two samples. So, let us say mu1 is the weight before, right, before going for training center, and this after is mu2, right. Weight once training center you have attended sessions on in training center, right. So, and the weight loss is more than 17 kg. So, how would you write it? So, first is this, let's you can have this null hypothesis and alternative hypothesis in two ways. The first is null hypothesis. Let us look at null hypothesis, mean mu1 minus mu2. So, we are saying mu1 is the more weightage, mu2 is the reduced weight, right. So, this is equal to 17 kg or 17 pounds for example. So, mu1 minus mu2 17 pounds, and what is the claim? It is more than 17. So, alternative hypothesis is mu1 minus mu2 greater than 17 pounds. So, this is the claim and null and alternative hypothesis, this HA alternative hypothesis. Let us look at this. So, this is how you can frame null and alternative hypothesis, right. So, average weight loss is 17 kg, it is more than 17 kg. Now, if you look at this question carefully, we are actually in fact not interested in weight before and after, but we are interested in difference, right. That is the point we try to prove in dependent samples. Is there any difference before and after or not, right? So, conceptually what we have is not two samples of before and after weights, but we will say there is only one sample of weight loss, and is that weight loss more than 17. So, we can rewrite these hypotheses like this. So, if the population of weight loss has mean this, we can restate our hypothesis as mean weight loss is 17 and mean weight loss has gone up or it is more than 17, right. So, this is a case of an upper tail test, this is a right tail test, right. So, you have got this rejection region, right, this is your rejection region, okay. So, you need to apply this sample standard deviation. So, d bar is this, it's 19.7, d bar is nothing but difference of all this and the average or the average of differences, right, minus mu d, this is what is your hypothesized mean which is 17, this is Hd upon root n, so 1.39. So, calculated t value is 1.90. So, this is how you should be calculating t value. So, t value is 1.90. Now, you need to, since you need to test this hypothesis at 0.05 significance level. So, the value of t is to be looked at in t table. So, at 0.05 significance level and at 9 degrees of freedom. Why 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, this n minus 1, because we have at the end of the day said that this is just one sample and we are looking whether weight loss is 17 or it is more than 17, right. So, this at 9 degrees of freedom. So, let us look at t value at 9 degrees of freedom. So, this is 9 degrees of freedom, 1.83 is this, okay. So, this is your 1.83, this is your, we are solving this question using critical value approach method. So, the critical value is 1.83, but the calculated t value is in rejection region 1.94. So, we will reject the null hypothesis, right. We will reject null hypothesis and we will say that the claim of the trainer is correct, because when we reject null hypothesis we accept alternative hypothesis and we are saying that weight loss is now more than 17 pounds, right. So, this is how you can solve a question like this, and we can solve this example using Minitab as well. So, let us work out how to solve this question using Minitab. So, you have got Minitab software. So, this part is worksheet and this is your output area. So, we will have data entry over here first. So, before weight loss, so this weight before weight loss and after is weight loss after attending fitness sessions, right. So, let us look at this. So, we have got 189, 202, 220, 189, 202, 220. Then we have got 207, 194, 177, 204, 194, I think this is 10, 194 and 177, right. Then the next data set is 193, 202, 208, 193, 202, 208 and finally 233. So, you have 10 data points, right. Let us look at weight after group of people attended training sessions, right, at training center, right, or fitness center. So, after data are this. So, 170, 179, 203, 170 is 170, 179 and 203, right. 192, 172, 161, 192, 172, 161, 174, 187, 186, 174, 187, 186 and finally 204. So, let us work out this question, and it is a paired sample test. So, we will go to state first, basic statistics, we will go to paired t-test, right. Now, we have got these two columns over here. So, sample 1 is the sample before weight loss. So, this is how you should select samples. Then for sample 2, which is after weight loss. Okay. Now, go to options. Now, let us check at what significance we have to check this hypothesis. It is at 95% significance level. Hypothesized difference. Now, this point is to be seen clearly. So, what we have said that since we are taking these two samples, so we will say that the hypothesized difference is 17, right. So, this is 17 and alternative hypothesis it's more than 17, isn't it? That is what we have said. In fact, we can solve this example just as a simple just t-test as well, right. So, we will click at OK, again OK. Let us look at output. So, p value is 0.042 and t value is 1.94. Let us check. So, t value is just what we have got over here, 1.94, which you can see here as well, right. Calculated t value. P value is 0.042. So, p value is 0.042, alpha is 0.05. So, p is less than alpha, so we will reject the null hypothesis. Since p is less than alpha, we will reject null hypothesis. Okay. So, this is how you can work out this question using Minitab. Let us look at next topic, which is hypothesis testing of two population proportion. So far we have seen means of dependent samples and independent samples. Let us compare population proportion of two groups or more than two groups. So, first we will look at population proportion of two groups, right. So, test hypothesis or a form of confidence interval for the difference between two population proportions, right. So, just like mu1 in previous case in previous example we have seen difference between mu1 and mu2. So, you can see here difference between pi 1 and pi 2, right. So, these are population proportions of two different populations, right. And of course, assumptions will remain same, so n pi and n into 1 minus pi both have to be greater than or equal to 5. And we will use this point estimate for the difference, which is this. We will use this to hypothesized population proportions. So, these are this is a case of two population proportion. So, the null hypothesis, we assume the null hypothesis is true. So, we assume that pi 1 and pi 2 are equal, right. So, this would be a null hypothesis. So, this is something called we will calculate pooled estimation for the overall proportion. So, this p bar is called pooled estimate of overall proportion, which is nothing but the sum of values in sample 1 and sample 2, and these are sample sizes of these two samples, right. So, these are number of items of interest in these two samples, right. This is how you should be calculating Z statistics when you calculate hypothesis testing of proportion of two samples, right. So, this is almost similar to what we have seen earlier, only the difference is this is now there in this equation. So, P bar, of course, we know how to calculate this, and P1 is this, P2 is this. Okay. So, we will work out couple of examples. So far as the distribution is concerned, or how the hypothesis, the distribution of hypothesis testing would look like, we have again this thing. So, this is a case of left tail test, is not it? This is an upper tail test and this is a two tail test, right. So, you can write null and alternative hypothesis either in this form or in this form, one and the same thing. This is how the distributions would look like. So, this is a case of left tail test because this symbol is less than type. This is right tail test or an upper tail test. This is the symbol, and this is a two tail test. You have got two rejection region because this symbol is not equal to type. So, let us look at an example. Is there a significant difference between proportion of men and proportion of women who will vote yes on proposition A? Question is there a significant difference between the proportion of men and the proportion of women who will vote yes on proposition A? In a random sample of 36 of 72 men and 31 of 50 women indicated that they would vote yes on proposition A. So, we have to test, is there any significant difference between these two proportions. So, you need to frame null and alternative hypothesis. So, how would you go ahead? This is a question on hypothesis testing of proportion, and there are two populations, right. So, null hypothesis would be what? It would be pi 1 is equal to pi 2, is not it, that they are same, and what we have to see, is there any significant difference is there in question, right. So, there is no significant difference. So, this is your alternative hypothesis. So, this is a case of two tail test, is not it. So, these two are rejection regions. So, let us work out this question. So, P1 is this 0.5 and P2 is 0.62. So, this is very simple, 36 by 72 and 31 by 50. Calculate pooled estimate of overall proportion. So, we have got number of items in sample 1 x1 which is 36, x2 31, and sample sizes are there, right, 72 and 50. So, this is 0.59, 0.549, right, is P bar, pooled estimate of overall proportion, right. Now, since you have got P bar, you have got P1 and P2, you have got N1 and N2. So, you just put this value, these values over here and calculate Z statistics. Of course, you will have to put pi 1 minus pi 2 is equal to 0, right, because they are same. So, this is what you have done, pi 1 minus pi 2 is equal to 0. So, P1 minus P2 is given over here, this is what you calculated, pooled proportion 0.549, and this how you will be getting Z statistics, which is it's minus 1.31, right. Now, is this T value in rejection region or non-rejection region? Yes, this is in non-rejection region. So, this region is non-rejection region, right? Non-rejection region, right? So, we will not reject null hypothesis, and we will say that the both men and women vote equally on proposition A, right? So, there is no significant difference in proportions who will vote yes between man and woman, right? So, man and woman equally vote on proposition A, right? So, we won't say that woman vote more compared to men, right? But if you look at just this P2 value, then you would conclude that woman would prefer proposition A more than men, right? But it is not like that. Statistically, they are one and the same thing. They vote in same direction, right? So, let us work out this example using Minitab software. Let us go to stat, basic statistics. It is 2P, right? This 2P. So, both samples in one column. No, we do not want to have that type of data entry system. So, let us look at summarized data. So, sample 1, sample 2, number of events and number of trials, right. So, let us look at for sample 1, it is 36 and 72. So, 72 trials and 32 are events, right. Similarly, for sample 2, we have got 31 and 50. 31 and 50, right. Options, we will go to options. At what significance level we are testing it? At 0.05, right. So, this is correct, 95%. Hypothesized difference is 0. Now, alternative hypothesis is that their alternative hypothesis is over here. So, they are it's not equal to type, right. So, difference is not equal to hypothesized difference. Estimate proportion separately? No, we do not want to use, we want to use the pool estimate of the proportion, right. Then click OK, again click OK. So, P value is 0.190, okay. Z value is minus 1.31, let us check. Yeah, so we are getting same T value, sorry, Z value minus 1.31. As far as P value is concerned, P value is this 0.190, 0.190. P value is point. So, the P value which we have calculated using Minitest software is 0.190. Now, just compare this P value with alpha value, which is 0.05, right. So, is P value less than alpha? No, P value is greater than alpha. So, we do not reject null hypothesis, isn't it. So, this is the conclusion we are getting using P value approach, and the same was the conclusion using critical value approach. As I have told you that there are multiple approaches, and one of them is confidence interval approach. So, if you wish, you can apply confidence interval approach for testing hypothesis, testing of two population proportion. So, this is the formula for that, which will not be doing any question using this particular method. So, we will move on to next question. So, let us say one more question on population proportion. So, let us say there are two drugs, drug 1 and drug 2, and you have to see how effective these drugs are when you test these drugs on two different sets of patients. So, when you give drug 1 to let us say 100 patients, it is effective on 71 patients, right, or P1 value is 0.71 or 71%. Drug 2, when you test it on 90 samples or 90 patients, it is effective on 64%, or in other words 64.44% of patients have positively reacted to this particular drug 2. Similarly, 71% patients positively reacted to drug 1. So, we have to check, are these two drugs equally effective? That is the question. Are these two drugs equally effective? So, null hypothesis will be, of course, pi 1 is equal to pi 2, and of course, it would be not equal to, right. So, this pi 1 minus pi 2 not equal to each other, right. So, you can work out this question. So, we have got P 1, then Q 1, just 1 minus P 1 is Q 1, P 2 is this, Q 2 is 1 minus P 2, right. So, this is our null hypothesis, that they are equal, right. So, you can have pi 1 minus pi 2 is equal to 0, in other words pi 1 is equal to pi 2, one and the same thing, right. Pooled variance or pooled estimate of overall proportion is this P bar, which is 0.67, and Z value is this. The difference of these two is 0, right. Pi 1 minus pi 2 is 0 in this case. So, when you calculate Z value, it is 0.973, and the critical table value at 0.05 significance level. So, the Z value would be 1.96. Okay. So, plus 1.96. So, this plus 1.96 and this is minus 1.96, and Z value is this, which is in non-rejection region. So, we will not reject null hypothesis, right, H naught. We will not reject null hypothesis. It means we will say that both the drugs are equally effective, right. It means pi 1 is equal to pi 2. Now, let us work out this example using Minitab. So, we will go to state, basic statistics, we will have 2p. So, let us look at the number of trials and number of events. So, for first one, it is 100 and it is 0.71, right. So, 171 would be the values over there. So, this 71 events and number of trials 100, right. That is why P 1 you will get as 0.71. Now, this is 19 into 0.644. So, you just do this calculation, 90 into 0.644, you will get some value. So, this is 58. So, you have to just take the rounded off value, right. You can't enter 57.5 or 57.8 over here, right. So, out of 90 trials, 58 is the number of events, right. Now, go to options, we will have confidence level as this 95%, alternative hypothesis will remain same, we have to use pooled estimate of the proportion, right. So, we will click at OK, again OK, yeah. So, Z value we are getting here is 0.97, which is same as here, right, when we calculated, right. Now, the p value is 0.334, 0.334 is the p value. P value is 0.334, alpha is 0.05. Is p less than alpha? No, p is greater than alpha. So, we do not reject null hypothesis. So, using p value approach, we are getting the same answer which we were getting using critical value approach. So, these are a couple of examples we have worked out on hypothesis testing of proportion. You should keep in mind this is quite an interesting topic on hypothesis testing of proportion, and whenever you are given two population proportions, you can compare whether there is a significant difference exists or not. So, with this let me finish today's session. We will have some more examples on this particular topic in next session. Thank you.